In pyridine, this is the pyridine. In pyridine, the electrophilic substitution reaction, when we add electrophile, this substitution can take place at position, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. It can take place at position 2, 3 or 4. Let's find out which is the most suitable position for this electrophile to attack and get attached. Firstly, what will we do? We will attach it at position 2. At that time, when we attach it at position 2, we will get an intermediate, which intermediate will be like this. This is, we're attaching it here, a positive charge will develop here, and the rest will remain same. This is actually the intermediate which we are getting. This intermediate is a resonance stabilizer. And how is it resonance stabilized? Let's find out. At position 2, this will be stabilized like this. I'm writing it this way again. This is the intermediate, this is the electrophile. Now what can happen? This will come here, this bond, it will break here and will move towards this, and when it moves towards this, you get another resonating structure, and that resonating structure will be like this. You have electrophile here now, and positive charge moves to this place, and this is another resonating structure. When we look at this resonating structure, we can make one more resonating structure where you have this moving here, and positive charge now moving to this place. So you can have this resonating structure, and here, okay, now the positive charge will develop on the nitrogen. So now further resonance is not possible. So we get 3 resonances, 1, 2 and 3. This is when the attack will take place at position 2, and then we will get an intermediate, and that intermediate is the resonance stabilized like this. Okay, now again, what will we do? We will try to attack this electrophilic attack at position 3. If it attacks at this position 3, so what will be the intermediate? This is at position 3. The intermediate will be like this. This will be the intermediate, and here it will be electrophile, and positive charge will develop here. Now look at this intermediate. It will be also a resonance stabilizer. How? Let's find out. This is the intermediate, the carbocation intermediate, and how will this be resonance stabilized? Let's find out. This will move, this bond will move towards this, from this side of nitrogen to this side of nitrogen, and you get the resonating structure, and that resonating structure will be like this. E will be at its own place, and you will have positive here. Now this positive can move like this. This positive charge will move to this place due to the delocalization, and you will have another resonating structure which will be like this. The electrophile will be at its own place, this bond here, now new bond develops, and you have positive charge here. So you have again 3 resonating structures for this intermediate, which is at position 3. So let's find out the other position of attack, position 4. If it attacks at position 4, now this is the final position where the attack will take place, and that is position 4. If we attack here at position 4, if it attacks at position 4, what will you get? What will you get? We will get this, and here and here. Now E will attack here, and you will have positive charge here. Now this will also get a resonance stabilized, and if you look at the resonance stabilization, how will that take place? This is E here, and you will have a resonating structure like this. This will be moving like this, and what will you get? You will get positive charge on the nitrogen, a double bond here, a double bond here, and electrophile at its own place. Now this will again move like this, and the positive charge will move towards this position, electrophile here, and these are the 3 resonant structures for position 4. So look at these 3. So you have looked at this position 2, you have 3 resonant structures. Position 3, you have again 3 resonant structures. Position 4, you have again 3 resonant structures. Out of these 3, the best, the most stable resonating structures are found in case of position 3. You see how? In case of position 2, then there are 2 resonating structures, and one is having positive charge on nitrogen, which makes it very unstable. Then again at position 4, the nitrogen is again developing a positive charge, so making this also unstable. And the position 3 is comparatively, you can see it is stabler one, because you don't have positive charge on the nitrogen. Therefore, when the electrophile will attack on this pyridine, it will try to attack at that position where it will form a stable intermediate, and stable intermediate therefore is formed at position 3 when it attacks at position 3. That is why electrophilic substitution of the pyridine takes place at position 3, not position 2 or position 4. That's it.